This video is the fifth video in the complex numbers set of videos, and in particular we're going to look at multiplying complex numbers. Firstly, you could be asked to multiply a complex number by a constant, and that constant is just any real number. It's the very same as it is in algebra. If you had x plus 3 and you were asked to multiply that by 3, you would just multiply the x by 3 and the 3 by 3. With a complex number, if you're asked to multiply it by a real number such as 2, you would multiply the real part by 2 and the imaginary part by 2. I think this is best explained by looking at example, and we'll look at example 5.1. It says multiply the complex number 5 plus 6i by 3. What I'm going to do first of all is write this out without the language. And here I'm going to then have 3 and I'm going to multiply that by 5 plus 6i. What will happen then is the 3 will multiply in by the 5 and also multiply into the 6. 3 by 5 will give us 15, and 3 by 6 will give us 18, and we'll have the I at the end. Therefore, when we multiplied 5 plus 6i by 3, we just multiplied both the real part and the imaginary part by 3. Secondly, you could be asked to multiply two complex numbers by each other. If you're asked to multiply two complex numbers by each other, you'll end up with an I squared. The most important thing when you're multiplying two complex numbers by each other is you remember I squared is equal to minus 1. At the top of every question in every exam that you might have on complex numbers, it will either tell you that the square root of minus 1 is equal to I, or that I squared is equal to minus 1, or both. The rest of multiplying complex numbers by complex numbers is best explained by going through an example. Example 5.2 says consider the complex numbers z1 is equal to 3 plus 5i and z2 is equal to 2 minus 4i. Express the following in the form a plus bi, where a, b are elements of the real numbers and I squared is equal to minus 1. As you can see in this question, they've told us I squared is equal to minus 1, and they've told us that the a and the b are real numbers, and the only part that is imaginary is the I. The first thing they want us to do in part A is multiply z1 by z2. To do that, what I'll have is a z1 being 3 plus 5i multiplied by 2 minus 4i. Here I'm going to multiply the brackets using the distributive property. So the 3 is going to multiply in by the 2, and it's going to multiply in by the 4i. The 5i is going to multiply in by the 2, and it's going to multiply in by the minus 4i. 3 by 2 will give us 6. 3 by minus 4 will give us minus 12i. 5i by 2 will give us 10i. And 5i by minus 4i will give us minus 20i squared. Looking at the like terms, we have minus 12i and plus 10i. So we'll end up with 6 minus 2i minus 20i squared. The key thing to note now is that I squared is equal to minus 1. So anytime we see an I squared, I'm going to replace it with minus 1. We'll then end up with 6 minus 2i minus 20 times minus 1. That will leave us with 6 minus 2i plus 20, leaving us at the end with an answer of 26 minus 2i. We've now multiplied z1 times z2, and the resulting complex number is 26 minus 2i. In part B, it asks us to find z1 squared. z1 is 3 plus 5i, and z1 squared will have 3 plus 5i squared. Hopefully you can remember that anything squared, be it x squared or 5 squared, is the thing multiplied by itself. So if we have 3 plus 5i squared, that is 3 plus 5i times 3 plus 5i. Multiplying that out again, it's going to be 3 multiplied by 3, 3 multiplied by 5i, 5i multiplied by 3, and 5i multiplied by 5i. 3 by 3 is 9. 3 by 5i will give us 15i. 5i times 3 will give us 15i. And finally, 5i times 5i will give us 25i squared. Next, I'm going to add the like terms. Here we have 15i and 15i. That will leave us with 9 plus 30i plus 25i squared. Again, going back to the fact that I squared is minus 1, I'm going to replace I squared with minus 1. And what I'll end up with is 9 plus 30i minus 25. Then we'll have 9 plus 30i minus 25. Adding the real parts together, we'll have 9 minus 25, which will give us minus 16 plus 30i. Example 5.3 is almost identical to example 5.1 and 5.2. A and B are exactly like 5.1, and C to F are exactly like example 5.2. The most important thing to remember is when you're multiplying two complex numbers by each other is that I squared is equal to minus 1. However, I do want to do one part of example 5.3. I want to do part E. And if we look at part E, it says multiply 3 plus 4i by 3 minus 4i. Multiplying that out, so I'm going to write it out first of all. What will happen here is we will have 3 by 3 and 3 by minus 4i, 4i by 3 and 4i by minus 4i. 3 by 3 will give us 9. 3 by minus 4i will give us minus 12i. 4i by 3 will give us plus 12i. And 4i by minus 4i will give us minus 16i squared. Here, adding the like terms, we have minus 12i plus 12i, which will actually cancel out to give us 0. And then we will have 9 minus 16i squared. However, we know that I squared is minus 1. So we replace I squared with minus 1. We'll end up with 9 plus 16, which will give us 25. The reason why I wanted to do part E is because if you have a complex number and you multiply it by another complex number that is almost identical to that complex number but has the sign in front of the imaginary part changed, then you'll end up with a real number answer because the imaginary parts will cancel out. So if the complex numbers are exactly the same, the 3 and the 4i, 3 and 4i, but the signs between the imaginary and the real are different, so the plus here and the negative here, you'll end up cancelling out the imaginary part and being left with the real part. So if I was you, I'd make sure that I could do part A down to F and use what I have on screen here to help you with part E if necessary. That brings this video to a close.